Hello, beautiful people. So you've heard me say over and over that I'm a big fan of Eva Maciejczyk. It's been a long 1.5 to 2 years to finally get our schedules together. I found her by way of Kevin Feeney and his book on the fly agaric, the compendium, which I talk about all the time. Eva has a chapter in it on the components and compounds in Amanita muscaria. She's one of the first researchers when I first found the mushroom, whose name that I recognized over and over in studying the compounds in Amanita. So I have just been a real big fan. I'm very nervous about this interview. I did a lot of preparation because a lot of the terms, the compounds, and the chemistry is very difficult, and I don't want to embarrass myself. This is a pretty big video. So I have to say, I know you are very busy. You have a full-time job. You're over there in Poland, which is an exciting place to be in spring of 2022. So considering all of this and how famous you are and your intelligence and what you're bringing to this community, thank you so much for being here.
I must confess that I feel that I'm not deserved for that. Because mostly what I read about and wrote about Amanita active compounds, it is not my own research. It is research in literature. So this is. It is not my my personal achievement to find that compounds and research on how they are acting on human body. So I feel I'm not deserving that.
So I love your humility, but what this is going to take is it's going to take thousands of people doing years of research because this thing is so incredibly complex. And what's valuable are the people that are bringing all of that together so that it is consumable, not only for people like me, but for other researchers to look at it and go, oh my God, I think she's onto something here when she's pulled that together. And I think that the role that you're playing in all of this is taking all this disparate information and researching it in a way that you can understand and compiling it in a way that we can understand. Because you have that brain, that biochemical brain that can do this, that can understand the literature and put it together for us. It's valuable, and it's going to pave the way for other people to see what you're writing, because you can choose your words in here. And I see the words you're choosing. They're not lost on me, and we're going to talk about that. So okay, let's get into it. You ready? Yes. Okay, ibotenic acid and muscimol. Deadly?
No. It is active component of Amanita muscaria, but it's not deadly. Of course, when you eat some dose, but even if you drink too much water, you can die after that. So it is all about the dose, but it is not poisonous as we are concerning the toxin in Amanita panther cap. The deadly poisonous Amanita, the white or slightly green one. So it is not this kind of substances. It is active component. We can call it neurotoxin. However, they are acting as a hallucinogenic components. So that's why they are neurotoxins.
Because so the problem that I have with that neurotoxic label is that those studies were done by injections into the brains of rats, not oral ingestion in humans. Do you feel like that you can make that assumption about it, that it's neurotoxic, and bring it over to eating it?
Before I answer that question, I have to say that I'm not a biopharmacologist or neuropharmacologist. Anyway, after ingestion of ibotenic acid, when you are eating the mushroom, it is partially or mostly metabolized to muscimol in the organism during an acidic decarboxylation step in gastrointestinal tract. Afterwards, part of these two compounds is carried to the brain, and another part passed through the organism quickly and unmetabolized via the systemic circulation. And we have to remember that ibotenic acid readily decarboxylates when exposed to heat and acidic conditions. So it is possible that after eating cooked or dried mushroom, or even after digestion process itself, only muscimol reaches the brain, causing the mushroom's famed psychotropic effects. So what I'm going to say is that when you are eating mushrooms, we have our brain-blood barrier. Of course, there are some researches which shows that those two components are able to go through that barrier. However, how much of it is going to our brain and how much it is discarded, I don't know that research on that, so it is hard to say. Saying that it is neurotoxin because above some doses, when you are injecting it in the mice's brain, it makes some damages. And when we are concerning eating mushrooms, we cannot compare those two things.
Okay.
So
let's move on. So Musca Zone. Musca Zone is the other metabolite or component you get when you decarboxylate ibotenic acid. And they're found in the European, but not American, right? Musca Zone.
Mm-hmm.
So they'll photoconvert to Musca Zone. Will it do that only like when it's in the ground still attached to the mycelium?
You know, from what I know, what I've read about Musca Zone, it is formed by the photochemical conversion of ibotenic acid and is produced mainly during the extraction of other compounds from fly agaric. And it was always been isolated as racemate and undergo decarboxylation. So these facts somehow suggest that this compound may be an artifact of isomerization of ibotenic acid during extraction process. So it is
it's more an artifact and not necessarily an onboard active component.
Yes. So maybe we are obtaining it during extraction process, during preparation the sample for analysis. So we aren't sure about it. So
that's fair. There's a lot we don't know. Okay,
yes.
Let's talk about muscarine. Muscarine is highly poisonous. Should we be worried about that?
I think not at all when we are talking about Amanita muscaria, because it was found in that mushroom only in trace amounts. So even if it is in a really small portion in Amanita, we shall not be afraid of that, because it is not like, again, I will say about that toxin which are in that deadly poisonous Amanita. It is of course poisonous, but not as much. So that really trace amount of muscarine in Amanita muscaria, we should not be afraid of it.
What are some of the symptoms of it if you get a little bit of it?
It is mentioned that it induces sweating. So, however,
we all know about the sweating in this mushroom. My God, the sweating.
Yes. So perhaps other compounds are also induce that kind of effect, because as I don't know which maximal or ibotenic acid increases body temperature. So if the body temperature is increased, so the sweating is natural after that. So maybe it is, because of that, not because of muscarine. So, but they also there was no research on that, so it is another question mark.
Right. I think we're going to have a lot of those. Okay, hydroxyproladine. It's not active to us, but it is where ibotenic acid and muscimol come from. So that kind of got me really excited when I read that, because I sort of had this idea in my mind that the mycelium put ibotenic acid together and then put it in the mushroom. I didn't realize there was on board this precursor. So is the precursor going up into the mushroom cap, and then while it's opening, it's going through the extra step to become ibotenic acid? Or is it like just in the does it get put together in the mycelium, or do we know that? Like what role does this play in this process to ibotenic acid? Do you know?
I'm not sure, but I've read about it, and about the biogenesis of ibotenic acid and muscimol, and also that hydroxyproladine all come from the same precursor, which is beta hydroxyglutamic acid. So I think the fungal metabolites are really amazing, because there are so many of that in many mushrooms, and scientists which are involved in research about that components, they are asking that question: why mushrooms are producing such compounds? So this is a really huge question.
I want to know.
I would like to also know that.
This is exciting. Hercinine. So in your chapter in the book, you said it's actually in really high amounts. And one of the things that jumped out to me was that Parkinson's cells that produce dopamine die, right? That's like one of the issues in Parkinson's.
Mm-hmm.
And hercinine potentially plays a role here
as radical scavenging properties and anti-apoptotic activity of that component. And that's why it is quite interesting when we are talking about Parkinson's disease.
So an apoptosis is a compound, hercinine is a compound that stops apoptosis, which is cell death. So hercinine can stop, but don't some cells need to die?
Apoptosis, when it is induced by some circumstances from the outside, let's say, I think it is not good for any cell. However, as scientists noticed, every cell after each round of duplicate, then it dies. So this is the natural apoptosis. But if the apoptosis is because of some induced circumstances, it is not good. So if in Parkinson's disease the cells is dying quicker, that's why this is really a huge problem in that disease.
And so that's why hercinine is actually really interesting then.
Yes, yes.
I wonder if that might be some of the roots of this being the mushroom of immortality. If it's slowing cell death and aging is, well, some of aging is cell death. That would be really cool. Stizzolobic acid and stizzolobinic acid. I hear that you have written, I've read it, that it's in small amounts.
Yes.
And that it's a stimulant and it is a precursor to dopamine. Of all the compounds, I think this one is the most interesting.
Only I can add, because doing research on that components when I was preparing that chapter, I also didn't have much time to studying the active part of that, how it is working on, for example, human body or for the cells or whatever. So I can say that I can just confirm what you did say, that it is that precursor of both of that amino acids are is DOPA.
So this, to me, y'all, is what is so fascinating about this mushroom, as if we haven't already covered enough fascinating information. If stizzolobic and stizzolobinic acids are the precursors to making dopamine, why is it in the mushroom? And what happens to it when we put it in our body?
No, it is not a precursor of dopamine. It is the dihydroxyphenylalanine, which is called DOPA, is precursor of that two compounds. So this is
stizzolobic and stizzolobinic?
Yes, as I remember. Maybe I'm wrong.
I don't know either. This is out of my wheelhouse. So I'll get back to us on that. Stizzolobic and stizzolobinic, though, I know that a lot of other people are really excited about these two. And I want to learn more about it. And like you said, there wasn't as much time to research it. But I honestly believe that once they finish working on the mast cell stuff and the sleep stuff and the stress stuff and the Parkinson stuff, that these two, stizzolobic and stizzolobinic, are going to be where we turn our attention. So in the book, you have, they've been detected in small amounts. Stizzolobic and, to a lesser extent, stizzolobinic have a stimulating effect on the rat spinal cord, but we can't always bring that over to humans. This is just,
yes.
Yeah.
However, you know, small amounts of something doesn't mean that it doesn't act somehow, because sometimes a really small dose is enough to make an effect. So
we'll see, huh? I know that I read that this mushroom does affect dopamine, but I don't know what, like, where, why, or how. I look at stuff like this and think in 10 years, this won't age well. People will look back and just laugh at this and be like, well, of course it did, or nope, totally wrong. Okay. You told me this really long word to just shorten it to a carboline compound. So thank you for that. But if y'all want to look it up, it is YL beta carboline 3 carboxylic acid. So today we're just going to call it a carboline compound. And yes, you say here that it has been determined to be in different foods.
Yes.
And also in this mushroom. And it's similar in structure to the MAOI and ayahuasca.
It is, yes, it is the structure. The beta carboline compounds are quite interesting because many of them has that active action and psychedelic or hallucinogenic action on human brain as it is in ayahuasca. So when I first I was interested by that component when I first read about that Amanita muscaria contain that. But after I research how that particular compound about how it is acting or not acting, because some research shows that it has no activity on human brain. So it was, from my perspective, when I was doing my PhD, I was disappointed because I was looking for hallucinogenic or active compounds. However, it is, you know, if there is some beta carbolin and it was detected, maybe it is also somehow maybe some artifact, or during the extraction something is going on with the with that compound. So in the mushroom it may be a different compound, but after the extraction and after analysis, when we saw the peak on our chromatogram or whatever, maybe it took a long way to the real component, to the what we have in our research results. So perhaps, or maybe I'm wrong here, maybe it is just like it is and has no active at all. So
well, that's what these discussions are about. And one of the reasons I wanted to do this is so that everyone understands how little we actually know. And when I keep telling everyone, y'all, we are just beginning to scratch the surface. We are in kindergarten. We are in the tiniest of understandings compared to what we will eventually know about this. And that's why this interview is not full of, it does this, it does that, it does this. It's full of, I don't know. I don't know. I don't know.
Sure. Yes.
Maybe.
Yes.
Beta indolacetic acid is a, well, what is it?
As far as I remember, it is a metabolic breakdown product of tryptophan or tryptamine, and it is often produced by bacteria which live in intestine. I don't know if I pronounce it correctly. Yeah. And some research show that it is an endogenous product in mammalian tissues. So so again, something what is in mammalian tissues is isolated from mushroom. So it is, wow.
Right. There's a lot of crossover with things that are in our bodies that are also in, and this is why, not just genetically, but I mean, for a lot of reasons, fungi tend to be more closely related to animals than to plants.
Yes.
I'm wondering why tryptamine compounds are in there. Pretty cool. Those are the actives. And if you read the chapter she wrote in the book, those are the ones, if you want to know more about it, that's what she covers. She covers a lot, but I mean, I condensed it about the actives. There's just so much more, so much more. I picked a few other compounds to talk about, but there's so much more. This chapter is very long, very well researched, but we're going to run through some of the others quickly. So there are proteins. There are enzymes that could potentially be medicines. And then the fats. Do you remember what some of the main fats? I can look it up.
I think that there was some phosphoglycerides and just let me think about it.
Linoleic, oleic, stearic,
Yes.
palmitic. Wow, lots.
Yes, it is a lot of carboxylic, the higher carboxylic acids, the fat carboxylic acids.
And also sphingolipids. Those seem to be pretty interesting.
Yes, sphingolipids are quite interesting because they are when we are talking about human or mammalian nervous cell, sphingolipids are in our myelin part of that nervous cells. So it is quite interesting that they are in mushroom. So it is quite interesting that this kind of components are in mushrooms, and in general, many biological processes are depend on sphingolipids. So, and also what we're talking about, that apoptosis is regulated by this kind of compounds.
So
and also
more cell death regulation.
Yes,
and nerve cell death, or just cells in general.
I just talk about an example where we can find sphingolipids, but also they are in some other parts of our body and our in different cells of human body or different organism. So, and it is really a really active group of compounds. So
where do beta glucans fit in all this?
In general, mushrooms are known to produce beta glucans, and also in Amanita muscaria, so it is not an exception. And this kind of compounds has shown some really crucial activity, because they have anti-inflammatory effects, and they produce inhibition of inflammatory pain, and some of them exhibited anti-tumor activity for some cancer, and also that which was found in Amanita muscaria. As I remember, there was research on that. So these are really nice substances, and also for us as maybe not only women, but still mostly women are looking for a perfect cream which will be hydrating, and also that kind of components are responsible for skin hydration. So many.
That makes sense. I make an anti-aging oil with an oil extract from Amanita and some other things in it. Cool. That's cool. Sterols.
Yes, and I think there is one really significant sterol, ergosterol. However, it is this kind of sterol is really it is not only for Amanita muscaria, it is also for, I think, every mushroom or in kingdom of fungi found a steroid. And it also has a really nice activity because when people start trying to and when they are focusing on that Chinese mushrooms, that medical mushrooms, and that there were research on on ergosterol. So it shows inhibitory properties, and that studies report that the tumor growth was disrupted without any side effects after oral administration of ergosterol. And it is because ergosterol has really, it acts on, it stops formation of new blood vessels in the cancer, in the tumor. So that's why it is, it acts as an anti-cancer medicament.
That's crazy that we have compounds in here that stop cell death in one area of the body or in one way, and then ergosterols that can cause tumor death by cutting off blood supply. Like there's so much contradiction in this mushroom, so much yin and yang, black and white, two sides. It's crazy. I know, maybe I'm just recognizing a pattern that doesn't necessarily exist, but I think it's interesting. Polysaccharides.
Yeah, we were talking about polysaccharides.
The ergosterol is a polysaccharide?
No. We before we were talking about that glucan. So this is the
beta glucans falls under that, and then mannitol.
Yes, mannitol is my favorite compound because during my PhD, when I was isolating substances from Amanita muscaria, it was, I think, one of 3 components which crystallize after extraction. And when I saw it, I was so excited that yes, I will have that my, for the result for a Nobel Prize. But when we did the study on what it was, and it was, for me, it was, oh my goodness, mannitol. It is also a common sugar polyol in most mushrooms. However, I was so frustrated that it is again a compound which is really common in many mushrooms. So I started to read about that component, and with no collocation to mushrooms. And then I noticed that there are some researchers on when they doing a study to give some medication in, I think it was connected with brain cancer, and they were trying to open brain blood barrier, and mannitol was that compound which was responsible to opening that blood-brain barrier. So, and when I read about that, it was my aha moment, because
Right?
I said to myself, that's why maybe when we are eating mushrooms and we are trying to compare it to equal amount of active components like muscimol or ibotenic acid, then when we are eating mushrooms, we have greater results after eating mushroom because it contains mannitol. So this was my assumption. However, I had never opportunity to do such experiment. So, however, I like this component because of that story.
Right. What about a roller coaster, man? That's crazy. Up, down, up, down. Well, is there any chance in the future you might get involved in any research on mannitol?
You know, when we are talking about Polish science, it is really hard to convince somebody to give you money for your research when your idea is kind of crazy idea.
It's the same everywhere.
So
nobody wants to hear about crazy ideas.
and you know, nobody wants to also make a science only for getting the knowledge. Now it has to have purpose in, you know, finding a solution for COVID-19, like we are here in our reality. Or in when we are talking about that research projects. However, nobody look at it when we could do that research, because from my perspective, after my research on that active components, and not only active components, but in Amanita muscaria chemistry, it is my conclusion that there is lack of research which was focused on the total chemistry composition of that mushroom. So there was, you know, about the beta glucans, so they were isolating only that. They were trying to find that hallucinogenic components, so they were focusing on that. So not a word about, you know, we did an experiment, we just, you know, make some extraction to find that non-polar components, semi-polar and polar components, and then analyze it completely. So it would be a really, really great research project. And I think it would be really difficult, because during my research on Amanita muscaria chemistry, it was really problematic, because when it comes to purifying one component, it was really difficult, because after many times of doing some column chromatography, I still have a mixture of few components, but there is so few amount of it to make another experiment to purify it. So it was really, really hard to do. So
yet this mushroom just keeps remaining elusive. So what you're saying is, every time you try to find out everything that's in it or try to isolate things, it's hard to get them alone, because they keep coming attached to other things. And then by the time you've extracted it and you've got several compounds and you want to try to extract one more, you don't have enough to do it by then. And I think in this way, until we get better technology or better ways of extracting, it may require learning more about the mushroom before we learn about how to isolate. And then the only reason we have to isolate is for research purposes, for writing it up and being able to say, okay, this is what it's actually made of. This is the structure of the compound, and this is what we think the compound is doing. But perhaps fungi, yet again, are going to laugh at us and say, we don't work like that. Take it or leave it. This is all you're going to get.
Yes, because perhaps a few compounds together makes that effect. And if in mushroom there is a huge amount of different kind of compounds, it is really hard to find that, connection, that those 3 are acting this way and those 4 acting that way. And if we disconnect them and trying to make a research how each of them doing or acting separately, then we have nothing, because the result it isn't as we observe after eating mushroom.
It reminds me of a lot of quantum work when we used to think that every isolated element acted alone. And then we started learning that quarks don't act alone. And perhaps we need to learn from that and start looking at compounds like this that stay together, that maybe not every single compound is going to act when it's isolated, and that will only act in conjunction. And because of that, you'll never separate them. And if you do, you wind up losing the ability to study them, because they're always going to act together in tandem. It's interesting.
Yes, it is very interesting.
I've kept you too long. I want to follow up quickly with, what are you currently working on?
Currently, I'm trying to use fruits and vegetable wastes as a source of valuable components, and I'm trying to use that components in cosmetics.
Really? That's
yes.
Awesome. Oh my
this
God,
is
that's so cool. Plant-based
yes.
cosmetics.
Yes, because there is a huge production of, let's say in Poland, tomatoes or many fruits which are produced in Poland, and there is a lot of waste after that production. So and still in that waste, in that pomace, there is a lot of active components. So why not we can use it and put it in cosmetics, or maybe in some supplements for eating, to put that active components which are discarded during the production of the food. Why not use it in some supplements or in cosmetics, because they are also act on our skin and they make the good things on our skin. So
that's great. Thank you for giving me your time. I'm going to upload this to YouTube. If they start coming after my channel again, then I will only have it on my website, but I will try to upload it to YouTube, and I don't know, we'll see how much I can get away with, but there's too many trigger words in here. But I will definitely have a trailer to it on YouTube. So that's what I do, is I make a trailer and then I post the videos on my website. So maybe if you have time, I'll send you the link. And if you have time to go see, if any of you have questions, it's a lot to ask. She's very busy, full-time job and all. But if you have time, maybe you could read the questions and see if you have anything you can say to any of them. I know right now it's a whole lot of I don't knows, a whole lot of we don't know, but I will reach out to you again if we have any major discoveries again about the mushroom, and maybe we can do this again and maybe have you back on sometime.
Okay, thank you very much.
I really appreciate your time.
It was really a pleasure to talk with you. Thank you very much.
I'm such a fan. So you'll hear from me again. I won't bother you too much, but every once in a while I'll send you some email follow-up questions or something. All right, y'all, if you appreciate the work that I am doing here, you can buy me a coffee. You can join our Patreon and get involved in our community. We're adding new Zoom meetings all the time, building a community of people who use this mushroom and who discuss the mushroom and are invested in it and interested in it. You can join us there. Okay. And we will see you all when I interview yet another famous person involved in the mushroom. And I appreciate all of you being here today.